we have Steve. Oh, we're going to start with Mike first. So Mike Thompson, let me introduce you. So here's Mike Thompson. He's the offering manager for the WebSphere application server, ND, which stands for Network Deployment. And he's contributor to the Linux kernel and WebSphere application server, and he's an international conference speaker. And I'll go back to introduce Steve. Steve will speak after Mike, but Steve is a usual suspect now, usual suspect speaker.
Yes.
Because Steve, this is your third time here, right? Yeah. So Steve has visited us before, and he's from Hursley, UK, from that lab. So, and he's IBM Java developer, leader, evangelist, contributor to Apache, Eclipse, and OpenJDK, and also an international conference speaker. So thank you again to both of you, and then I'll pass on the mic to Mike. Mike to Mike. Thank you.
Howdy. All right. Well, Mary, thank you for the introduction. Clearly, I'm super important.
Yes, you are.
So we're going to talk about modernization strategies and things you need to be aware of. But I sort of wanted to quickly introduce myself. So it is true my current job role is an offering manager. It's what pretty much everyone else in the industry calls a product manager. I am a technical offering manager. That means I focus more on the technical side. I used to be a developer. I used to be an architect. I've done a variety of roles inside of IBM. A lot of that on the WebSphere side. I've got my fancy little WebSphere jacket. I'm not here to talk to you about WebSphere, though. I'm here to talk to you about general modernization stuff. And I'm also a part-time developer advocate. I say part-time because basically when Steve says, hey, I want you to come talk at a conference with me, I say, okay. But that's not my primary job role. So, modernization. Who here feels like they're doing it? Presumably you're here because you're interested in learning more. So what is modernization? What goes into modernization? Is it the code, right? Hey, we used to do Java EE and now we want to do something a little fancier, maybe Spring, maybe microprofile, maybe we want to get a little more sexy in the code base. Is it the tools? Oh, I've got GitHub and VS Code. I'm modern now. I'm done. I can be done. This is my modernization journey. Is it the runtime, right? Oh, I'm on WebSphere or WebLogic or something. I need something a little more nimble, a little more agile. Let me go Spring Boot. Let me go Node.js, right? Get into the polyglot space. Is it the architecture? Well, we're a 12-factor app, so we're modern, right? We're doing microservices, so we're modern. There's containerization, so we're modern. Is it the platform that I've been deployed to, right? Am I on cloud? Am I in Kubernetes? Is that enough? The answer is no, it isn't. Because there are other elements of modernization that need to be considered. We're very good about talking about technology. We are at a Java user group after all. But there's dimensions of this. There's the people. There's priorities, right? Where are you putting your time? Where are you putting your dollars? There's skills and processes, right? I'm sure everyone in this room has been told you're agile at one point or another. Whether or not you feel like you're agile is a very different thing. And you know, there's DevOps and there's all this modern concept about how we build, how we package, how we deploy. And fundamentally, a lot of this is about culture. If you are in a culture that is not willing to change, modernization is going to be a painful uphill battle. And I've organized my chart this way specifically because it's important to think about at least the two dimensions of modernization. There is the technology. That is an important piece, right? But there's also what I'll call the soft costs, right? And you need to be aware of that. And at the end of the day, that is going to be your biggest hurdle. We're all smart. We can all learn technology, but it's really, really hard to convince my executive sponsor that we need to do this and we need to spend the time and the prioritization if they're not going to see the value. So it is hard to start a modernization project. I work with a lot of clients doing a lot of different things. I've seen some start, I've seen some die on the vine. And what it usually boils down to is there are differing priorities and competing goals within an organization that basically means that they like the idea of modernization. It sounds really good, but when they actually open it up and look at how much it's going to cost them, they're usually not willing to expend that level of effort, right? If you get past that and you say, okay, we agree we need to modernize, how are we going to do it? You put 10 people in a room and they're going to have 10 different opinions, right? And converging on any kind of a consensus on how you move forward technically is a very big challenge, and that is absolutely something that needs to at least be agreed to explore and approach early on. And modernization isn't going to happen overnight. It is a multi-year journey in many cases. So you need to have an agreement within the organization, an agreement in your executive chain that say, we are going to fund this. It's going to take time, but we understand that there are clear benefits to doing this, so we're gonna understand, the effort. So what does modernization even mean anyway? Well, we're talking about application modernization typically. The office that I work in just went modernized, or we got modernized on our floor, which really meant new carpet and a fresh coat of paint. Sure, we're modernized now. But when we're talking about application modernization, we're talking about code, we're talking about things that are running your business. These things matter, they're often mission critical, and you need to balance the reality of that thing continuing to run for your business and moving that forward. The problem with the term app modernization is it's often oversimplified to be thinking about things like, oh, well, it's the ear or the war. And it's not just that, right? Applications are big, complex systems. You probably have integration technologies, you probably got messaging going on, you certainly have a database somewhere. All of that comes into the picture. And at least in 2 clients that I can think of immediately off the top of my head, they've gotten bogged down in their modernization conversation because they're trying to effectively boil the ocean and say, how do we modernize the universe at the same time? That's a very difficult problem, right? You'll want to segment and take a structured approach. And I talk a little bit about how you might go about that later. But just understand that the application is a big, complex thing. And modernizing that means everything from modernizing your processes and your practices to actually changing the code and how it works and how it's deployed. So is everyone in the room self-identifying as a enterprise application developer? Probably work on semi-complex systems at least. Okay, a little bit maybe. The application hairball, not a term I coined, but one that I thought was kind of appropriate, is in an organization, if you're doing anything of substance, you're going to have multiple parts of the system communicating with each other, right? It isn't just a single ear file and a single database and you're good, right? There's lots of things that are all talking to each other. And in some cases, these could be distributed individual components running separately. In some cases, they could be built together in a monolith, right? You've got a variety of WAR files packaged up as an ear file or however you want to think about it. And at the end of the day, the reason the term hairball is up there is because these are tightly coupled, interwoven, spaghetti code kind of structure where you can't easily pull on a single thread and decouple the system, right? The reality is, unless you've intentionally designed it to be that way, it is almost certainly not that way, right? Because very naturally, these things become interconnected and interwoven through really no fault of our own, other than the fact that we have pressures to build things and do them quickly, and I've cut corners, I'm sure everyone in this room has, that leads to this big jumbled mess. So we have to accept in our heart of hearts that applications are big complex beasts, and that means modernizing them is similarly hard. And it really means we have to ask ourselves a question: to modernize or not modernize? That is the question. Not everything should be modernized. Right? We talk a lot about application modernization. There's this whole big push to understand it and to embrace it. Microservices are everywhere. Containers are the latest thing. Not everything needs to be changed. There are some really good things you need to understand that will influence the decision on why modernize at all. But go into any project with a little bit of skepticism and say, is this modernization effort going to bear any fruit for me? Because if it's not, don't waste your time. So what would cause me to actually want to modernize? Well, number one, if you can't develop the features that you need to deliver for your business, for the value that you're trying to provide, and the reason you can't do that is because it's about the technologies that you've chosen or the architecture of your application, that is a very good sign that it might be time to modernize. A really good example of this is Spotify. They had a monolithic architecture originally, and over time they realized that they couldn't deliver at the rate and pace that they wanted because they were constantly revving the monolith. So they spent the time and energy and effort to decompose that into a microservice architecture so that the individual parts of the business could deliver independently, right? That was a technology problem that they had that they recognized that was limiting their ability to move forward. So that was a reason that they chose to modernize. The other reason is that the fundamental architecture of your application is limiting you from even delivering any new function, right? And that's usually this notion of technical debt, where you've got this fragile system because it wasn't built with tests, so it's super brittle, and every time you make a change, you break 12 other things. Been there, done that. WebSphere application server, it's gone through those days. Or because the choices that you made in the architecture or the tools that you were using to implement that in the past don't give you the leverage and the flexibility that you need to be able to move forward. And the last reason, and this is a compelling reason to modernize, but it is usually the hardest to justify, is that your application is expensive to maintain and extend because of those technology choices. And that is really limiting your ability to respond, right? So these are all technology problems. And it will require a technology solution, but that doesn't mean that the technology is sufficient for you to fully embrace and fully modernize. So IBM has a services arm, as you guys surely know, and they have learned a lot over the years working with various clients. And the things that they've learned that have enabled us to help customers be successful in that modernization journey is that you need to have the organizational agreement that you're going to put in the required investment up front and sustain it over time, right? If you cannot get that buy-in, you will not succeed. This is not the kind of thing that a group of, well-intended developers can do in their spare time, right? This is organizational change that has to happen, and that requires buy-in all the way up and down the stack, left and right, up and down. Everybody needs to be on board with this effort to modernize. It also might mean that the way your organization is actually structured needs to change. Depending on how you want to tackle modernization, depending on what processes you want to adopt, if you have an organizational structure that is, I've got a development team, they report to a completely separate line of the business, and an operations team that report to a separate line of the business, you're going to have organizational problems with prioritization and agreement and coordination on getting things done. So there is this organizational aspect that may or may not require you to change, but is definitely something you need to be aware of, and this is actually something that we've struggled with. The last thing is that you need to have agreement that you need to reevaluate your architecture, your development processes, and your operational processes, because at the end of the day, modernization isn't just the technology. We can't just adopt Spring Boot and say we're done and we're modern. That is not sufficient, right? The whole point of modernizing is to allow you to go faster and be more successful, so that requires you to change very often the way you operate today. Hopefully, everyone in this room doesn't feel like they do this, but I have worked with plenty of clients where they have the throw it over the wall model of, I'm a developer, I write it, I give it my operations team, and it's a one-way communication street, and my ops guys just deal with it unless there's a critical problem, then they talk to the developer, right? That is not a modern way to operate. You may still have separate teams, but you need that bidirectional communication for flow of information. And I'd like to say that IBM has actually done this. So I've been in the Webster organization for 13 years, something like that. When I joined, we were waterfall. We were doing 2-year like deliveries and the whole like requirements gathering, and we had a big database of line items and separate development organizations from test organizations. It was this whole mess. And we decided to start embracing Agile in 2008. And it took us about 10 years to get to the point where we actually feel like we're kind of Agile now. And what that has meant is we've changed the way our organization is structured. We've changed the way our teams are structured. There are no more separate development and test teams. Where there is one team that delivers one aspect of the product, right? Components or whatever you want to think about it. They're one team. Everyone's responsible for making sure that thing gets delivered. And what that has meant over the course of the years is that we've been able to go from this big 2-year release cycle to ultimately what we do now in the open, which is deliver monthly. That, if you had said 10 years ago that you're going to be delivering monthly releases and they're going to be of higher quality than what you used to deliver, nobody would have believed you, right? They would have agreed with the principle, but they would have said, I don't know how we're going to get there. And that is because these journeys often are highly iterative. You will change things slowly with an eye on the end game, and when you get there, it may be better or worse than you had originally intended, but you will be able to make progress. But it requires top-down support, right? And when we rolled this out for the first time, we actually spent about a week educating not the developers, not the testers, but our executive chain, saying this is what we're going to do and this is why we're going to do it, and you are going to have to accept that this is going to be a bumpy ride for the next, I think at the time we said 4 years. It turned out to be 10. But it can be done, but know that it takes time. All right, so that's all the soft cost stuff that you need to understand. Don't try and start a modernization project if you don't have organizational buy-in, right? That's the 10-second version of everything that I just said. But when we want to actually talk about technology strategies, there's a few different ways you can think about what am I going to do with the thing that I have. Well, I can modernize it, right? That's what we're talking about here, and I'll explain what some of those options are in a moment. You could just migrate it, and by migrate here, I literally mean like lift and shift. Like, hey, it's running on-prem right now. I want to get out of the data center game, call up Amazon and say, hey, give me some hardware, and then boom, put it over there, right? You're not modernizing anything when you do that. You're changing who you pay, right? You're not really gaining any developer efficiency if all you're doing is deploying on a VM on premises to a VM in the cloud, right? You might save some money, but you're not fundamentally going faster. The other thing you need to consider, that initial question of do I modernize or not, is certain things aren't worth it. If it's not strategic, if it's stable and it's just working and you're going to replace it, you have the options to replace the thing, right? Either build your own new or buy a solution, right? We do see clients do that. IBM has done that. We had built our own ticketing system, and now we use Salesforce, right? So we retired the old system and we brought a new one in. You could retain the system that you have and just leave it. It ain't broke, don't fix it, right? Just let it run and just accept the fact that it's going to stay where it is. Or you could just get rid of it all together and say, this is no longer a solution, this is no longer a business problem that this company has, this organization has, we don't need it anymore, because you've either solved it in a different way or it just stops being relevant. So you might want to modernize something, but you also might not. And that's why you need to go into any modernization project with a little bit of skepticism and say, is it even worth spending any time to do anything in this case? But let's assume that we do. Like, let's take a look at an application that is strategic. The organization wants to continue to develop it. It's critical to the business. How do we move it forward? Well, you've got a couple different steps. The first of which is just simply containerize the damn thing, right? Hey, it exists, it works, we run on VMs today. It'd be nice if we could just put it in a container and deploy it on our strategic container platform, wrap it up, package it that way, and go. that is valid. That is a very valid first step for you to take on that journey of modernization. You may also want to actually repackage the artifact itself. So if I have a big monolithic ear file that's got 12 different WAR files in it, there may be some seams in that ear file that I could say, well, maybe it doesn't need to be one big ear file, maybe it could be 3. And I can break it up that way, and now I can deploy them independently, and now I can iterate, I can rev those 3 things separately. I could then take the next step, which is actually begin to refactor the code. Fundamentally go in there and start ripping some pieces apart and say, well, this looks like a good candidate for a microservice. Let's go in there, pull that out, and begin to isolate it and begin to develop it completely independently from the rest of the system. There's other things that you can do with your existing application that would allow you to modernize it, which is to externalize some of the capabilities that it has, right? We have built up lots of business logic over the years. Sometimes we haven't made it particularly easy to call into and access. So maybe we want to just put some APIs initially around the thing that we've built. Now, what you're going to get out of that is some business value to be able to call into that existing system, and you may do that within the monolith or do it as like a front end. But that is a valid strategy to begin to modernize the assets that you have, or you could enrich them and say, well, I want to do some AI or blockchain or whatever the hip, sexy thing of the moment is, and I want to start putting that logic into my application as well. So externalizing and enriching are 2 things that you can do with your existing assets to begin to modernize them, begin to add some capability, expose the thing that you've got. But I'm more interested in the journey of going from monolith to microservice. So how do I begin to do that? Well, we've sort of figured out through working with a lot of clients, there's a fairly solid approach to take here. And it starts with my current monolith running in a VM, running on traditional runtime like a TWAS or a WebLogic or something. The first thing you should be thinking about is not the technology problem, it's that soft problem, right? It's the process problem. If you can't get your developers and your operations team to begin to work together early on in this process, doesn't matter what you do with the technology, you're not really going to get faster, you're not going to become more agile. So the first step really is about process change. Then once you have an agreed to approach to begin to operate in a way that would be more modern, then you begin adopting the technology, you can start to containerize, you can start to repackage, and ultimately start to refactor. So again, repeating the message that some things will never leave their current state, right? Either because they're not important or whatever. Know that when you're doing an analysis of your application estate, you should be categorizing the applications in a way that says this is a good candidate to modernize, either because we think it's going to be easy or we know that it's strategic or what have you, and create a separate bucket that says here's all the stuff we're never going to worry about. And if you are putting things in that bucket, know that there are options for you, right? You could lift them, you could shift them, you can move them to the cloud and put them on VMs and such. But these are going to be a category of applications that you are not going to spend any time from a development and operations team worrying about because they just don't matter for a modernization project. Once you've identified a good candidate to start with, and I always advocate for selecting something that you think is going to be easy because an early win will help you begin the momentum of actually modernizing. Start thinking about how you're going to improve the processes around that application, right? It's your processes and it's your organizational structure that is most likely to get in the way of any modernization project being successful. When we did our whole agile journey with WebSphere, that was one of the first things that we did. Literally the first thing was we said there's no more separate development teams and test teams reporting to separate managers. It's now one development team reporting to one manager, so there isn't this, it's not my priority problem, right? If you have that kind of a dysfunction in your organization, tackle that first, because you won't be able to get alignment and agreement to move forward if you don't. The other things you can try to do, and they may or may not be easy to do depending on the sort of tools you already use, is try to start building automation for things like DevOps pipelines in place. If you're not doing automated testing, start. If you're not using like really good build tools that automate these end to end, and hopefully it's not some guy on the weekend doing a compile on his laptop and then emailing a thing, like that would be really bad. Start fixing that right away, because once you begin to learn those skills, you'll be able to start applying them to the rest of the journey. And as far as you can, try and treat everything like code, right? Infrastructure as code, configuration as code, version control things, because as you move forward towards a more automated environment, you're gonna want that auditability, and you're gonna want that confidence and the ability to roll back. So once you've begun to think about the soft angle, once you begin to think about the processes, now we can focus on things like containerizing and repackaging and actually changing the things that we've built over the years and beginning to take advantage of new technology. So there's a concrete benefit to just containerizing the thing that you already have. People familiar with the concept of a blast radius? Right? The idea of the blast radius is if I change one thing and it has this big ripple effect in my system, then it has a very large blast radius. If I can change that same thing and then a failure occurs and the impact is small, I have a limited blast radius. By being able to containerize things, you now have snapshotted versions of everything. It's really easy to deploy. It's really easy to roll back. You begin to isolate where problems can get injected in the system, and you have this advantage of containerization where you can quickly roll back things. If anyone's ever tried to deploy a new version of an application in an application server, you know that there are usually lots and lots of steps, and unless you're very good about snapshotting your VM, trying to do a rollback is a pain in the butt. Right? Oh, I updated to a new version of the product, and now it doesn't work, or something regressed. I have to roll it back, I have to do all this stuff. Yeah, it's doable, but it takes time. It's so much easier if I could just say stop my old container and stop my new container, run my old one, because now I knew that thing used to work, it's fully snapshotted, it's fully versioned. You also get the idea of this immutability, right? The immutability is actually really key for you to have reliable, repeatable processes, because when you have that container and you run it, whether you run it today or you run it 2 days from now or 2 months from now or 2 years from now, that container is fully snapshotted, it's not going to change its contents, and you have the confidence that that is going to work. If you're in an organization that is doing deployments by running scripts and they're human generated and you have to do that, in n number of systems, you have lots of points of failure for humans to introduce error. And I don't know how accurate the statistic is, but there's a statistic that floats around that says like 70% of production problems are in fact created by human error. So by beginning to remove some of those human elements, we have higher repeatability. And there's some real value that happens once you begin to do this containerization piece. Today, right, I've got a whole bunch of applications, they're running on my middleware, they've all got their own logging, their own monitoring, there might be a central system somewhere, but usually all of these things begin to have sort of their own stack, right? What we do for WebSphere is different from WebLogic, which is different from JBoss, which is different from yada yada. If I can containerize everything and deploy it to a common platform, I can take advantage of those common platform services and begin to have one operational experience. I like to call this operational modernization. You haven't really modernized the app. Sure, you've containerized it, great. You haven't fundamentally changed what the app does, how the app does its thing, but what you've done is you've shifted a lot of those unique skill sets that you have for various middleware components into a more common operational model based on containers, using some sort of a system, probably Kubernetes, whatever you want to use. And then you can reuse these things so that you begin to modernize the operational aspects of what you've been building, and you can get that value early and usually fairly easily without having to go through the whole application refactoring phase. And in many ways, we've actually already started doing this in the industry, and we just haven't really thought about it. Right? If you think about your traditional Java EE kind of application, you've got your UI elements, right? Your servlets, your JSPs, whatever. You've got your business logic encoded. You've probably got some integration with like an MQ in there somewhere, and then you've got your database. Well, since Web 2.0, we've sort of started shifting that around to this single page architecture model where now instead of having a whole bunch of JSPs and servlets, I just deliver an HTML with a whole bunch of JavaScript in its own individual modules that then calls into my back-end system. That is beginning to split up the UI aspects of your application, right? No one would call that microservices, but you begin to separate the concerns of your application. The next logical step is segmenting your business logic. And that's really where microservices comes in, right? I have an application that is responsible for handling a specific set of logic for whatever that need is, billing, back end for front end pattern, what have you. You can also begin to microserviceize, you can begin to decompose, decouple your integration logic, right? You don't have to go through a massive enterprise service bus. You can start breaking that stuff down so those pieces begin to get individually managed, individually delivered. And oftentimes, if you read a lot about microservices, they will prescribe your data being more decoupled and tightly coupled with a microservice so that each microservice has its own database. Now that might not be universally applicable, right? You might still have the mammoth Oracle database somewhere sitting in your organization because that oftentimes is the hardest thing to break down. But as you begin to break all these things up, you begin to isolate the towers of function rather than having it all delivered as the monolith. You get these individual pieces. And that's really where this refactoring concept comes in, right? Now that I've got a set of processes that are enabling me to be more agile, now that I've got containerization in place and I can operate on these things fairly consistently, I can begin to start refactoring this and really embracing those things like 12-factor microservices, etc., that the industry likes to talk a lot about. Those things are fantastic if you're doing greenfield development. If you're building something net new, embrace those right away. But if you're doing a modernization project, embracing those from the beginning is not sufficient. And the reason it's usually sufficient for greenfield development is because you've probably already thought about your organizational structure and your tools and all of that stuff ahead of time, because in order to do those things, you have to have considered them. And more often than not, when we talk to customers about modernization projects, they start thinking technology first and they forget about all of this soft cost. So there was a really interesting example that IBM did, which was we used to have this system that would basically give you all like the legal notifications and such, and that was delivered as a monolith running on-prem. One of the sort of product managers for that did a quick analysis, and they said, if we change the way we deliver this, and we actually deliver it on IBM public cloud, we'll reduce our operating costs, which currently are $17,000 a month, down to $500, right? Saving millions of dollars over like 3 years or something. That business case was the reason the modernization project was allowed to start, right? You will very often need, and this goes back to why modernize at all, you will need to have some kind of a justification to begin a development project like this. It is not just new shiny, right? That's never going to be sufficient. But if you can show, the technology is causing a problem, we can get reduced costs, we can get a solid business benefit out of this, we can actually begin to tackle the challenge at hand and begin to modernize. So I want to sort of start summarizing and say, there are some trade-offs, as you'd imagine, with these various approaches. Generally, doing nothing is a fairly cheap choice in the here and now, but there's consequences to not doing things if you have problems, right? More often than not, the reason people want to modernize is because they see a problem in their environment, maybe they can't move fast enough. The cost of inaction generally means that the costs of doing development will continue to go up. If you're not going to take any action at all, you're usually going to pay for that on the back end. However, as you begin to select the other options like containerizing, repackaging, or refactoring, the cost to take action jumps quite significantly because you've chosen to take some level of action. But the long-term payoff is greater through greater developer productivity and greater developer agility, right? That needs to be understood by the organization. When we started this in WebSphere and we tried to modernize ourselves, we spent a ton of time just trying to relearn how to do things like development pipelines and writing automated tests. Where we are now allows us to do these things really quickly, and we're really down in this refactor category because of the kinds of things that we've done, right? We're building an app server, so we're not like a containerized thing. We're not Spotify or Netflix, right? That isn't our model. But we have fundamentally rethought our development processes, our development practices, and the way that we build and deliver the product. So we're definitely down in this brown line column of refactor, and it took a long time to get there. But the upshot has been that our developers are more productive than they ever have been because we now build things in smaller pieces, we deliver them in smaller chunks, and we actually have like automated builds that run and test everything every single day. So you do gain developer productivity over time with these modernization exercises, but the cost to start them is really high. And that's the key point that you need to be aware of, and that your executive team and your whoever's funding the project need to be aware of. You're not going to get payoff immediately. You might get some small wins, but the full realization of value is a delayed benefit. So I would be remiss if I didn't close on this, which is microservices should not be your goal. We talk a lot about microservices, but microservices are not a panacea, right? They're a tool that will help you if you have specific problems, right? If you have a very large application, if that application needs to be developed and iterated on at more of a component level than the whole application itself, if you want to be able to accelerate your rate and pace and change of parts of the application independent from others, microservices are a great architectural tool that you can embrace. However, it's also very easy to over-engineer what is a relatively simple problem in a lot of cases, right? All of these things, the replatforming, the repackaging, the refactoring, the containerization, the microservice architecture, these are all tools in the toolbox for you to be able to use in a modernization journey. You do not have to do all of them, right? You can stop at any given point based on the needs of the application and what you desire to get out of it. So to just close all this out and sort of summarize on what you need to be thinking of in a modernization journey, you need to be making sure that your development leadership is on board. You need to make sure that they understand what the tangible benefits are, right? What are the skills that we're going to need to foster? Do we need to hire people, right? Do we need to bring in consultants or something? Like, how are we going to bootstrap this? Your operations team will obviously be impacted. They need to be fully brought on board, right? If they need to get skilled up in Kubernetes, if they need to understand how the CI/CD pipelines work so that they understand how things are making its way into their environments, those things matter. Very often organizations have like architectural guilds or governance bodies that say we need to have these levels of compliance. How are you going to ensure that in your organization? Those parties need to be involved. And of course, as I've said repeatedly through this, right, you need to make sure that the business is brought on board so that they're willing to essentially fund the effort. And that's it. Tackle your soft costs, understand what they are, begin thinking about your processes as the first real step towards modernization, and then worry about the tools and the technologies that you can begin to embrace. Because if you don't do those first two things, the organization, the effort will go through fits and starts and very likely not be successful. I've seen it happen. Don't let that happen to you. All right, and I'm going to hand it over to Steve to talk about technology.
I don't know how to follow you. What I'm going to talk about sort of connects. We'll see how this goes. So Mike was very upbeat, positive, and mine's not quite.
Cautionary tale?
Cautionary, yes. Okay, so My name is Steve Poole, I work for IBM. I've been doing Java VM development, so as I said before, it was one. I was very early on involved in the JVM team, and my career has been Java. But I also have led DevOps teams, and right now I do this, developer advocacy. It's great to come out and talk to people. And the world has changed for us. Even those of us who produce Java, the world has changed, okay? Because of this thing. Who's got a cloud? Okay, yeah, okay, you know. It's there, okay? It's what we've always wanted. But it's not really the story, okay? The story is this stuff. Cloud, containers. You ask people who's using containers, and we can agree or disagree on what a container means, but people have this sort of vision, and it's great, and you can put your software in these things, all these wonderful things happen. Mike was saying, you just containerize, and you're done, okay? Because, look, whoops, go back one. You can take containers anywhere. You can do anything with containers. These are houses that were containers. Not that you'd want to live in them, apparently, because they get quite cold because they're made of metal. But there we go, okay? You can build art from them. They're versatile. These are real containers. Okay, cool. Containers give you new opportunities. We can put them together and go off and do great stuff. And basically, as long as the answer is container, we can say, we're done, it's fantastic. The world is going to be brilliant. And it is sort of, because what we've got out of this is new ways of delivering software, creating software. So the old stuff, the traditional app to hardware thing, well, we're putting some of those in containers. Monolith in a box. Okay. That's an option, right? Wrong with that? Or maybe you're putting multiple containers, you do microservices. That's cool, nothing wrong with that. Maybe you're doing some of the other stuff. Maybe you're going to serverless, microframeworks. They're just different options. So maybe you're going down to serverless where you're just putting a function. Maybe you're not even using a container, right? But all these options are available to you. And of course, pretty much all of this is based on the fact that you're going to run it on a cloud or a cluster. Okay, that's cool. So what, as an industry, we've basically decided is containers are the future. Because of the flexibility and be able to create new application types, immutability and repeatability. The concept is I can create a container, and wherever I run it, it will behave the same way. That is a very powerful thing, because we can build systems, because we're not getting human beings to construct things, and they do it differently or not. The conference that Mike and I this week, I was right at the beginning doing some workshops, and we had to set up 25 laptops. And normally we bring in VMware and we're done. And we couldn't do that on these machines, so we had to set them up by hand. Script, 25 machines, and on the day we'd forgotten to do this on that one and this on this one, and we just, it was not the greatest. If we had immutability and repeatability, we'd have done automated it. Okay, so it says there are immediate challenges. There are immediate challenges. The most obvious one in general is that cloud computing is not perfect. And you can read about issues and challenges with it. Okay, but it's a cloud. A little bit of rain, it's not going to hurt you, is it? Okay. So, what you have to do is start taking it apart and look at what the challenges are. So if you want to deliver any of this stuff, you need some other stuff. You need a shipyard. Containers, shipyard. Okay. You've got to put your containers somewhere. And that's usually Docker Swarm, Cloud Foundry, Kubernetes, Amazon, a place. And that's okay, we've got those. And then you need to manage the complexities. You need visualization tools, analysis tools, management tools, because that's life for you. If it's not now, it will be, because containers grow. Is that the right word? They just go out. It becomes very quickly. It can become very unmanageable because you have individual containers and versions of them, and it's just can get really out of hand. So What tools do you have to manage your environment? When you're looking at something new piece of technology, you might quite often go to Google and say, what are the top tools I should use? And I did that, and I said, top tools for Java, and I got listed like 3 or 4. And you go, okay, they're the usual sorts of things. If you do Kubernetes, and you say, what are the top tools for Kubernetes? Well, I found this one, 50 useful tools. And I went through it, and I went, yeah, they're all very useful. The tail here is that much as cloud computing is the thing that we're all relying on and we're trying to do modernization and stuff like that, it is still got problems because it's at a level of infancy. There's a lot going on. There's a lot of plumbing. You have to remember that clusters are very complicated. To give you the benefits of them, there's a lot of plumbing going on, and hence there are lots of tools. This is the CNCF front, not the front page, CNCF list of tools. We'll talk about the CNCF later, but this is the tool space that you're in. And as a developer, you may not actually see much of this stuff, but this is what the sort of stuff you're relying on. Okay, so there's more to follow. So we have an environment where it's actually quite hard for us to build the solutions that we want. Okay, and the consequences quite often are, one, these containers that are immutable and supposed to be fantastic turn out to be full of rubbish. Okay, and we'll talk about why that is, or they don't behave the way that we expect them to. That can get people upset. And the other truth is, if you've ever done this, debugging containerized solutions can be painful. Okay? In reality, it's quite tough being, that one keeps popping up. It's quite tough being a container developer. So I'm going to draw you some pictures as to why that is. And we can all sympathize with each other, okay? So you have choices. Forget your application design choices. No, you've got even better choices. What do you have? What do you run here? There's your first choice, okay? And then you've got to pick your version of Java, okay? And then you've got to pick your version of frameworks. And bearing in mind that we're doing microservices, the chances are that it's not a matter of picking one of them. You're probably going to pick all of them, just do all the different combinations. And then you've got a build cycle. You've got to make some choices there. Maven or Gradle, or something else. Git, SCM, you make choices. Okay? And then you've got to put your IDEs in. Yeah. And the test tools that you have, take your pick there, and the databases, and other test tools, and maybe even IDE plugins, find bugs and things like that. Ha! But there's more. Let's shove that to one side. Animation is great. Ta-da! Because what happens when you finish? That's your desktop life, and you chuck your code into Git, and you commit it, and then you trigger off a Jenkins thing, which, guess what? Basically does what you did differently on its machine. It doesn't use the same tools you use, maybe a bit, but it does it differently. Oh, and it probably does it 2 or 3 times, at the very least, because you have different stages. Yes? All to produce that thing that you stick on your server. And that's old life. Right? Now you're doing modern life. You add in all the different programming languages that you've learned. Okay? As a Java programmer, you're probably learning new programming languages because you've got no choice. More frameworks. You pick them. Okay? And then you've got to add containers. So everything that you did on your desk, right? Now you're going to do it in a Docker container too. Yes? You do Control S. Then you might do Maven build or Gradle build or whatever. And then you're going to do a Docker version of that as well. All various combinations of those. Okay? And guess what? Jenkins does that too. Okay? And that, no, come on, to produce this wonderful image. So, the challenge for us now is that from that, the journey from there to there, which we were all promised was going to be easy and we'd end up with a little immutable Docker image that would flow around the system, is not true. For loads of reasons, almost nobody would go from that to that without going through a whole sequence of other things. Okay? And the problem for us is, right, the tools that we have in these pipelines are heavy. And so what you have on your desk isn't what you have running on the service, because they're either different tools or they use a different scale, because we don't have ways of bringing the stuff down. Okay? And the life cycle can get complicated too. So you end up doing things on your desk that, again, that it's not a full. You'll do Control S, maybe, and then occasionally you do a full build. You don't do full builds all the time because it takes too long. You don't run all the tests. You cut them down. And it also turns out that this is a problem. That at the end of the day, everything that takes place in our arc of producing stuff, pretty much all of it is sitting in the code in some form that's sitting on your desk. Not absolutely everything, but pretty much all of it. Okay? All sorts of stuff can be decisions that you as a developer can influence. So because of those three aspects, we end up with this situation where we've got multiple steps of verification. Okay? So you've got Control S. You save your code, it gets built. That's one opinion. Opinion 0 is what you thought should happen. Opinion 1 is what the IDE thinks. Opinion 2 is when you do, I don't know, Maven package or whatever. Okay? And then you can do it in the container. That's another one. Then you're going to repeat those things on the build system. Okay? Multiple times, how many stages you have. And eventually you're going to put it in production, and then you're going to find out what it really did. Yeah? Yeah. And we do all this because we're not certain that what the developer, you, have done is going to work. So it's an irony. This is a good one. People say they say Americans don't get irony. So here's a test. Do you think it's ironic, right, that the person who knows what we're supposed to, what the code is supposed to do, you as the developer, rather than being empowered by your process, finds it actually gets in the way, right? Because you have all these extra steps that you have to take place. Okay, yeah, it's a bit yuck, right? But having said that, it's been around for ages. Containers are just making it worse because we have all these multiple combinations that you have to deal with. But guess what? Yeah, that's nothing. It's getting worse. If you're doing containerized development, your build process changes. Because if you're doing real HA, you're deploying to a cluster, you're trying to provide full 24/7 high availability type things, one of the failing points can be your CI system. So you don't want to have that. You don't want to have one system, because if it fails, you can't deliver. So the answer is, the modern world is not one big server with lots of connections and projects and little build engines. The new world looks like this. Lots of little pipelines, a bunch of different sorts of tools that you will have. So each of your projects, your microservices, whatever, will have their own pipelines, because you can scale that, and if one fails, it doesn't matter because the others haven't. Okay? So life is complex. You've got more choices. Your tooling CI processes is really complicated. It's going to change beyond belief because this is a different way of doing things. And if that isn't enough, your target operating system is going to change. You may not have got to this bit yet, but believe me, it's very close. Containers are not just Docker. There are other variations of containers, which I'll talk about in a sec. One of the versions of those things like Containerd. Anybody heard of Container Linux? Anybody tried Container Linux? No? Okay. So you know when you've got Linux and you want to install something, you do perhaps get install or yum something, or maybe use Ansible or Chef or something like that to install stuff, yes? What you're doing is you're taking a pristine system and you're modifying it. You're signing in, you're running in command. Container Linuxes don't work that way. These are the real cattle. The idea of Container Linux is it is configured when it is booted, which of course in a cloud means when it's brought up for the first time, and you have a whole process, completely different process for telling a system what it's going to have on it and how it's going to be configured. And that happens at boot time, at instantiation time. That's it. You can't change it. And in fact, on some of them, I was playing around with the Red Hat thing got one called Core OS. If you SSH into the machine, which you can do, it sets a little flag to tell you the machine is dirty. Okay. The new world is containerized operating systems. So lots of the tools that you might have learned in the automation tools are going to end up changing to deal with these sorts of environments. Hey, more stuff changing. So there we are. We thought we were getting simplicity and immutability and an easier life. But right now it turns out that that's far from it. Because the tools, the complexity around all this is containers are changing everything because we still believe in the value, but the tools are just not keeping up. Because when you saw that picture, that's how difficult it is, and it is just in this sort of space. So it's a little bit wetter than you might have thought. Anybody want to go home and not use Docker anymore? No? Okay. Right. Okay. So that was the bad news. So let's talk about the good news. It is not all bad. Right. But it is, if you haven't realized that the container world, it is early days. Yes, we've all used Amazon and Google to deploy things, but when you start using this stuff in production at scale, it turns out it's a lot more complicated because of where we are in the life cycle of all this. So there are organizations that are helping bring it together, and I would really encourage you to have a good look and just start watching these guys, because a lot of the tooling that you'll be using is around now. A lot of it is aimed at operational, but there's a lot of stuff coming around that you would be using as a developer. So CNCF. I managed to cut off the numbers, but look, they're getting loads of projects. It's an umbrella organization. Everybody in this space is joining or joined, and it's all part of bringing some clarity to it. So the CNCF are providing roadmaps, which of course you can't see, but basically helping you understand what you should be looking at and why, and trying to bring some clarity. There are lots of tools out there that are competing. You saw my list of 50 tools. That's just one slice. There are lots of tools out there, and I couldn't say go look at A or B, but you have to start getting your head around the fact that you've got a long journey. There were these two tools I talked about or showed in the CD thing. There's a CD foundation, the Linux Foundation are running that. So if you can't use Jenkins, what can you use? Well, you start looking at things like Jenkins X or Tekton. These are pipelines. Fundamentally the same sorts of things that you'd have in Jenkins, but pulled out into separate deployment things. This is where we're going to be evolving the new CI/CD systems. Okay. Now I said also that containers are more than Linux. Things may look like a container because it has the same shape, but it's not true. There's a project called the Moby project, which is a nod to Docker. The Docker guys are part of this project as well. The containers that you're using, the Docker file processor you're using, it's not the only way of building containers. And Docker files are pretty simple. There are other things that we can do to build containers. And this group is looking at two things. Standardizing the interfaces so that different implementations can come along and you can create them for different purposes, and looking at different tools to create containers in different ways. Because as I said, you look at creating a Docker file and a very simple set of instructions. It's not the only way to do that. So that is really worth looking, because you ain't seen nothing yet. Now, recently I've got involved in this thing called Cabanero.io, which Mike is also involved in. It is an IBM open source project, but don't hold that against it. We're doing this with other partners as well, Red Hat and crew. what we're trying to do is bring some extra clarity. So the whole process of creating source of software is in the same sort of state as the Kubernetes, what I showed you with the CNCF, the tool space. Okay, we're working very hard to give you all the plumbing. We're not very good at giving you the tools to install the plumbing, and so there are lots of things coming along. There's tools in the IDE space, tools in the development space, tools in the templating space for creating applications, a whole bunch of stuff around Kubernetes, trying to make it easier. Because you can imagine that if you have all that level of complexity under you, right now it's coming up and bubbling up and it's hitting you. And what we want to do is get rid of that and get us back to the point where you can say, I have some standard tools, however many they are, that let me do my job and create containers and deploy to clusters. As a developer, with all the development tools that you would expect, should be there. Okay. So I'm going to touch on two, just to talk about them, because they're probably the most relevant to developers out this set. There are others. I mean, I'm just picking on these two because I can talk about them. And I think they're interesting for themselves. So the first one is the Eclipse project called CodeWind. So, you know this thing I had, all these different stages? Well, let's put in some bits and pieces. So you know in all your different stages in a pipeline, you've got different tools. And one of the challenges we have is that lots of the tools that take place in the process aren't coming down to you as a developer. Okay. So what CodeWind is doing is trying to figure out how to get the tools that you need to prove that your stuff is okay in a container. Remember, because you're developing a container. So performance tools, profiling tools, testing tools. How do we get those back into the IDE and connected to the container that you've created and the container that you're developing without you having to do lots of heavy lifting. Now CodeWind also offers another little value which is interesting. We have a lot of these boxes. What CodeWind can do for you is it can help you reduce the number of options. Let me show you that in a sec. So what CodeWind gives you, this is just as an example of where we're thinking it all goes, is you have an IDE, you have your code base on your desk, you have a development lifecycle, don't you? Control S, build. Okay, it's called the inner loop. It's the bit that always happens all the time. So we can take that inner loop, the bit that you would do as part of the IDE or part as your Maven build, and make it one, and put it inside a container. So the build process can be containerized, which I'm sure a lot of you have already done. But this is connected to the IDE, so the IDE doesn't have to do the incremental compilation anymore. It's done by this container. So there's only one opinion. There's not two. It's not what the control. There's not three. There was what did the IDE think? What did your Maven build think? What did your Docker build think? With this approach, we can take those three and turn them into one. Okay, and put all the tools in a container. And the idea is that CodeWind's job is to figure out what you're doing and offer you the appropriate tools. Okay? Just trying to make life easier. And then the other one, so for me, of all the tools that I've seen out of this thing, this is the killer app. This for me is the thing where we're going to make a big difference. So Apsley is a CLI, no UI. But what Apsley does is it looks at this and it says, hey, I can replace all of those different opinions on what your build should do with just one, a containerized option. And I'll explain that in a second. But it also does something else, and this is what I think is the twist that really is going to make life a lot easier for us. I said earlier on about the fact that code tends to be, the code that drives your process tends to be sitting on your desk. Okay? And that you as a developer can change things that might break something and you don't know because you can't get the tools to prove it. Okay? And so you end up with this horrible situation. What code absolutely does, it says, we're going to make that an invalid assumption. What we're going to do is take the code that you have in your tree and rethink it. So we're going to give you a stack. So a container with all the build tools you need to build your project. We're going to give you a template. So you can easily, and this is all stuff you can create your own versions of this. And then you can have a template. So you can say to yourself or your team, I want to do a spring build or something. I want to do a spring project. So I can do absolutely init spring. Okay? And I'll get two things. I'll get some build tools come down, a Docker image, and I'll have on my desk some code laid out. Okay? So that code ends up on my desktop. But look, it's not the whole lot. It's not everything in my source tree. It's just the two things that as a developer I care about. The code I'm writing and the tests I run. Okay? Everything else is still in the image. Right? And when you use absolutely run, it creates a container that brings together all the metadata, and it mounts your local code that's running just the bits that you need all together into one container, and provides to the build process a logical view combining all the metadata and the source code. Okay? And it provides that environment, that logical view, to everything on your desktop. So your IDEs, Control S, all those, it's all one build process. And the code that you as a developer can change is less than we used to have. Now this is a structure. So any project can change their minds as to what you want to have there. But think about what it means. It means two things here. One is, if you use this tool, then you can have, because it's a CLI, it's a build tool, you can use this in all the build stages, because it's never going to change. So you don't have to worry about configuring different processes. You just do absolutely build. And this structure of separating the metadata from the stuff that developers care about means your metadata is immutable. As a developer, you cannot get inside the Docker image that's got the metadata. So, what might you put in metadata? You might put dependencies in, or some dependencies, and let the developer have others. So imagine if you go, okay, I've got a security vulnerability, I need to fix it. You can update the stack, and every developer who's coding and relying on your team's stack now has that dependency fixed across the board. Okay? Right? And if the developer themselves, you've got some new guy and you don't want him to change things, he's like, I don't want to change these dependencies, and he does, okay, that can break you. But in this structure, we're going, that's not going to happen, because the stuff that is important to the operations teams and to your team leads and to your managers and whatever, you can stick into these stacks. Okay? So at the end of the day, we know containers are here to go, to stay. There's nothing we can do about it. What the Cabanero project is trying to do is reduce the complexity, and I just touched on stuff, right? But overall, as an industry, we're all very conscious of the fact that we've got to change the stuff that we give you. As early adopters of this, you may already have discovered just some of the fun you can have. Who's ever tried to install Kubernetes? Okay. Who's been successful in the first go? Okay. Who's been surprised? Yeah. Okay. The whole point of this is containers are fantastic, but we've got behind in how we use them as developers. And there are projects happening right now that you should keep your eye on: Cabanero, CNCF, and others. Just keep watching it, okay? And then when it's your turn, you start doing this stuff, and you find it's not as simple or as you were led to believe, you can come back to my talk and go, see, Steve told you. Okay. Anyway, that's it. Thank you.